Hello everybody, welcome to the world of Autocad 3D. This video tutorial is meant for those who are already familiar with Autocad 2D drafting and on a lookout for a tutorial to start with Autocad 3D. If you have learned Autocad 3D on your own and if you feel that your knowledge is not systematic, then this video is meant for you. In order to make things more simple and systematic, I have divided this entire video into two parts. In the first part, I deal with the basics of Autocad 3D and the technique to generate various engineering views such as isometrics, perspectives, oblique views, auxiliary projections and elevations in a click of a button. And in the second part, I deal with a basic Autocad 3D modeling as well as the concept of user coordinate setup or UCS in detail. By the time you complete both the tutorials, I'm sure that you will develop a clear insights on the fundamentals of Autocad 3D. So friends, let's dive into these tutorials and I wish you the very best.
So let's get started. Before performing 3D modeling, we should make sure that the workspace corresponding to the 3D modeling is active. So I'll click on this particular icon over here and you can see that the drafting and annotation interface is presently active. So I'll just click on 3D modeling. So once you click on that, you will see commands specific to 3D modeling and visualization in the ribbon panel. When you work in 2 dimension, you are concerned only about the X and Y axis. But there is also a Z axis which remains perpendicular to the X and Y. The directions of X and Y can be easily understood by looking at this UCS icon. You know that X is pointed towards right and Y is pointed in the upward direction. But what about the Z axis? The direction of Z axis is obtained by applying a simple rule called left hand rule. This rule states that when the user holds the left hand, the forefinger pointed towards the positive X direction and the thumb towards the positive Y, then the middle finger will represent the direction of the positive Z axis. No matter where you are in 3D space, you can identify the direction of the positive Z axis if you can simply apply this rule. Now, let me start my introduction to 3D by creating a rectangle with a length of 150 units and a width of 75 units. So before I create such a rectangle, I should set my invisible drawing boundaries using the limits command. I'll type limits using the keyboard and I'll set the lower left corner at 0, 0. I'll set the upper right corner at a value which is greater than the length of the rectangle. So I'll give 200, 200. Now I'll give a zoom command followed by all option to bring the limits within the screen. Now I'll just disable my grid by clicking on the grid button, or you can press the F7 key because this grid is not required. Now I'll create the rectangle using the rectangle command. So I'll click on rectangle from the draw panel and I'll click my lower left corner at this location using the mouse. Now I'll go to dimension option, just click on dimension and I'll give the length of the rectangle as 150 and the width of the rectangle as 75. Now I can pick the opposite corner point here using the mouse. Next I'm going to extrude this rectangle through a distance of 75 units. Using this extrude command, I can do that. But before moving on to extrusion, let's try to understand the meaning of extrusion. The extrusion is the process of generating a surface from a profile in the positive Z-axis direction. When you extrude this rectangle, the software generates a surface from this profile in the positive Z-axis direction. And from the left-hand rule, it's clear that the positive Z-axis direction is pointed towards you. Now, let's look at an illustration to get a better understanding of extrusion. On my screen, I have a circle and a rectangle, and I'm going to extrude these two profiles. From this demonstration, it's clear that a circle extruded will result in a cylinder, and a rectangle extruded will result in a rectangular block. Okay, let's extrude this rectangle. So I'll click on the extrude command in the modeling panel and I'll select the rectangle to be extruded and I'll give an enter. When I'm asked to give the height of extrusion, I'll give the value 75. Now it got extruded. Even if it is extruded, you cannot make out any change in the appearance of this object. Why? That's because this view is a top view. How will you know that it's a top view? Simply by looking at the view cube, which you see over here, you can be sure about the view. The view cube will give you an idea about the various faces of an object which are visible. You will also get an idea about the type of view. For example, a top view or a front elevation or a 3D isometric view, etc. There are two different ways to control the display of this view cube. If you want to turn off the view cube, you can give the view cube command. So I'll give view cube and it can take the value 1 or 0. If you give 0, you are suppressing the display of this object. You can give the view cube command and give the value 1 to turn it on. Okay, now it's back. The second method is right click on the screen and you just go to options and you will get the options dialog box. Here you have the 3D modeling tab. Just activate 3D modeling tab and you can disable the 2D wireframe visual style and all other visual style which you see under display view cube option, and click on apply to turn off the view cube. You can just activate these two options to bring it back to the display. Now it's clear that it's a top view. It's just like looking from a top of a building. When you take such a view, you simply cannot judge the height of that building. Now if you want to see the height of extrusion which is given and the surface which is generated because of extrusion, you have two alternatives. Let's go back to the demonstration to find out these two alternatives. You can rotate the object in 3D space to see the thickness as you see in the demonstration. But when you rotate an object, you should specify the axis as well as the angle about which the object is to be rotated in 3D space. So that is relatively difficult. So let's consider the next alternative. Instead of rotating the object, we can rotate the view. And that is a better alternative. You know why? Because it can be easily done with the help of the view cube. When you analyze the view cube, you can see that around the view cube, the various directions are marked. We have south side here, west, north and east sides are marked. And when you hover the mouse over the view cube, you will see a number of clickable locations. Each of these locations are called hotspots. When you click on this hotspot, you can see that the software automatically takes you to 3D view in which the front, top and left faces of this object is exposed. And you get a view from the southwest side. So you can call it as a southwest isometric view. It is called an isometric view because these two edges are equally inclined with the horizontal and the front, left and top faces are equally exposed. So when you click on the hotspot of the view cube, you can rotate your view to see the extruded surface, and the software also gives you a perfect southwest isometric view, which is one of the most commonly used views in engineering visualization. At the upper left corner of the screen, you can control the visual style as well as the type of view. When you click on the visual style, you get various styles. The default style is the 2D wireframe, in which the object is represented as a transparent model and the boundaries are indicated with lines and arcs. And when you go for conceptual, Autocad uses cool and warm colors to represent the various faces, and it won't show any other color. And when you select hidden, the software gives you a hidden representation in which the display of the back faces are hidden. And when you go for realistic, it will give you a more realistic shading with the help of materials and colors if the material is applied. If you select a shaded, it will give you just a flat shade, but it won't show any materials. And if you click on shaded with edges, you can see the shades applied on the faces as well as the presence of edges. When you select shades with gray, it just applies a monochromatic shades on the various faces. And when you click on sketchy, it will give you a hand-drawn effect. And if you click on wireframe again, you will get a transparent representation, and you can go for X-ray. You will get a more X-ray like representation with a semi-transparent effect. So these are the various visual styles. I'll go back to realistic representation. Now let's see the different types of view. You can also change the view by clicking over here. Instead of southwest isometric, you can go for southeast isometric. Okay. You can also move on to a northeast isometric view and any other views. For example, if you want a front elevation, simply by clicking over here, you can get a front elevation. I'll just go back to the southwest isometric. All these views can also be obtained by clicking on the various hotspots of the view cube. But I recommend you to make use of the various options available over here to change your views, because that is more handy and more convenient. And if you want, you can also switch over to a perspective projection by clicking on the perspective option here. This is a perspective view. The objects in front of us tend to appear bigger, and the objects away from us tend to appear smaller. That is a perspective effect. You can also get back to perspective or parallel projection by right clicking on the view cube, and you can select perspective or parallel projection depending upon your requirement. Now we have discussed two different methods to generate views. The first method is by using the view cube, and the second method is by clicking on the view menu at the upper left corner of the screen. But there is a third method available in Autocad using which we can generate views. For that, you have to click on this particular arrow which you see at the right side of the quick access toolbar, and you just click on the show menu bar button. When you click on that button, you will get menu bars, and you can get all the pull down menus which you see on the older versions of Autocad. You can click on the view menu, and here you have the visual style button using which you can control various visual styles which you have seen before. And you can also change the views by clicking on the 3D views menu. So if you are using the older versions of Autocad, you can stick to this method to generate views as well as to change your visual styles. So we have discussed three different methods in Autocad to generate 3D views. Generating views using the view cube has some speciality. For example, along with the view cube, you can see a home button. When you click on this button, you can always restore the southwest perspective view, because that view is the default view. Suppose if I click on this particular hotspot in the view cube, you have got a southeast isometric. If you want to reset your view back to the home view, you can just click on the home button to get the southwest perspective view. So that is one speciality of the view cube. Second speciality is that the various faces of an object is identified based on the view cube. So the view cube will act as a compass in AutoCAD. For example, simply by looking at the view cube, you can be sure that this is a front face, because you can relate each face of an object with the corresponding face in the view cube. So this is the front face, and this is a top face, and this is a left face. The second advantage is that using the view cube, you can generate all types of views such as isometrics, elevations and perspectives. Apart from that, you can generate a special view called auxiliary view, which is possible only through view cube. How will you generate such a view? I'll just take my cursor over here, and I'll just give a click on this hotspot. Now you can see that in this view, the front and the top face is exposed, and the rest of the faces are hidden. Now I'll just give a click on this particular hotspot of the view cube, and you can see that in this view, the left and the top faces are exposed. Such a view can be called as an auxiliary view because two planes are projected on a plane inclined at an angle of 45 degrees in space. Let's look at this illustration to get a better understanding of this view. Here, these two faces are projected on a plane in space to get this view, and this plane is called an auxiliary plane. Let's take a view from the other side. Such views are often used as supplementary views to describe a complex object. Let's go back to the southwest isometric view by clicking on this particular hotspot of the view cube. Now I'll change the projection type to parallel. Another important point to be kept in mind before generating views using the view cube is that before we generate a view using the view cube, your coordinate setup should be set at WCS. WCS stands for the World Coordinate Setup, and that is a default coordinate setup in AutoCAD. When you open a new drawing, you will be in the World Coordinate Setup. But as a user, you have got the freedom to create coordinate setup of your own for various applications. Such a coordinate setup created by the user is called a UCS, or User Coordinate Setup. I'll show you how we can set a new UCS. I'll just click on New UCS. Now it will ask you to define the origin point of the new coordinate setup. I'll click this corner. Now it will ask you for the x-axis direction. I'll click here. Then it will ask you for the point on the XY plane. So I'll click a point here. Now you can see that you have created a new coordinate setup, and this is called a User Coordinate Setup. But when you look at the view cube now, this face is a top face and this is a back face. Previously that was a top face. In order to avoid such a situation, it is always better to set the coordinate setup to WCS or world coordinate setup before we generate a view using the view cube. At the upper left corner of the screen, we can see the viewport controls. When you click there, you will get a number of useful options related with view generation. For example, when you click on viewport configuration list, you will get a number of viewports. Each of this configuration will let you divide your screen into a number of subscreens. For example, if I select 2 vertical, your screen will get divided into 2 vertical subscreens. I can keep a particular view here, and I can just click to activate this viewport, and I can have a different view here. For example, I can have a southeast isometric view here. So 2 views of an object displayed simultaneously on the screen. You can just click on the same viewport control icon, and you can just click on maximize viewport to get the previous viewport back. At any point of time, you can just click on restore viewport to get the previous viewport configuration. Previously, when we have discussed about view cubes, we have seen 2 different methods to control the display of view cube. But this method can be treated as a third method to control the display of view cube. This is the simplest and easiest way. Just click over here to enable and disable the display of view cube. Here you have a navigation bar option. Once you click it, you will see the navigation bar. So navigation bar will let you navigate through your viewport using a variety of tools. For example, if you just click on pan, you can pan your display. When you click on zoom extends option, you will get maximum possible magnification. When you click on orbit, you can move the camera around the object. When you just click on the steering wheel, you will get full navigation controls. So steering wheel is meant for an experienced 3D user. When you take the cursor on the zoom tool, for example, when you just click it, you can perform magnification. And once you leave it, you will get back to the steering wheel. Once you click on orbit, you can just orbit the object about a pivot point. Once you leave it, you will again get back to the same navigation tool. Now if I want, I can just click on pan to get the pan tool, and I can leave it. And here I have a rewind option available. So rewind option will give you a rewind tool using which you can go through the previous positions of the object. Okay, the Autocad can memorize all the previous positions of the object. You can just click on any desired thumbnail to reach on to that particular position. For example, if I want this position, I can just click the mouse there to get that position back. You can just click on this cross sign to close the steering wheel. In the navigation bar, we have a show motion button which is used to create camera-based animations to conduct presentations. We will have an exclusive video on camera animations in Autocad on a later stage. And once you create a particular view, you can always save this view using the view command. For that, just click on the Visualize tab and click on View Manager, and you can just click on the New button and you give a particular name for the view. I'll call it as, say, My View. You can give any name for this view and just give Apply. And that particular view will appear in the Views tab along with the standard view names. You can just click on the saved view name to restore it. In the Visualize tab, along with the saved view name, you can also see a number of standard views such as a top, a front, a bottom, northeast, etc. So in this tutorial, we have seen different methods in Autocad to generate standard engineering views. We will just recollect this information by generating different views using different methods. We will generate a southeast isometric by clicking on this particular hotspot of the view cube. But we should make sure that the world coordinate setup is active before we generate the view. Now I'll just click on this hotspot to generate southeast isometric. Next, I'll use the 3D views option in the view menu to generate a southwest isometric. So I'll click on southwest isometric. Next, I'll generate a northeast isometric view using the view option available in the upper left corner of the screen. So I'll click on northeast isometric. Now I've got that view. Next, I'll use the Visualize tab to generate a top view. So I'll click on Visualize tab and I'll click on top. So we have covered the various possibilities in view generation in Autocad 3D. We have also discussed the different navigation tools which will let you navigate a 3D model in Autocad. Hope this tutorial was useful, and it's a good starter to explore the vast topic of Autocad 3D modeling and visualization. In the next tutorial, we will see the basics of 3D modeling and the concept of user coordinate setup in detail. Thanks for your time.